Hello and welcome to SolarWorks for Illinois, the monthly webinar from Continental Electrical. Today we're going to talk about how rooftop solar pays back for your business in Illinois. We're going to answer 5 key questions about that. I'm Tim Montague, your host. Today is August 28th. Let's dive into SolarWorks for Illinois. So our agenda today, we're going to talk about 5 questions. What does solar PV cost? What is the payback period? Which facilities can benefit from solar energy anyway? And what about solar plus battery storage? Finally, we're going to address the big one, which is why Illinois is now a top solar market in the United States. So what does solar cost? Solar PV is semiconductor-based technology that was established in 1954 here in New Jersey, and it makes electricity from sunlight. In the 1970s, solar cost over $100 a watt, which is why it was only used in remote applications like satellites and remote mountaintop telecommunications. Today, the price of solar is less than $1 a watt. We can buy solar modules in the 40 to 50 cent range. Since 2010, the cost of solar has decreased 75%. What that means is solar is now going mainstream. If you live on the coasts, on the East Coast or the West Coast, you see solar everywhere. Here in the Midwest, the cost of energy is very low, and that has been a barrier to entry, but we now have a great opportunity in Illinois, and the market is growing like wildfire. So here's an example of what a small, medium, and large commercial system might cost. These are turnkey installation prices. For small commercial, you're looking at $250 to $3 a watt. So a 20 kW system might cost $50,000 to $60,000. For a medium commercial system, you're looking at $225 to $250 a watt. So a 100 kW system would cost $225,000 to $250,000. Then we have large commercial. As you see, the price comes down as the scale of the project goes up. Looking at $1.50 to $2 a watt for large commercial. We're talking a megawatt scale system. A megawatt would cost $1.5 million to $2 million. What is the payback period? The only reason we install solar in our facilities is that it pays back. In Illinois, historically, we had a payback period of 10 years or more. And that's because power is very cheap and solar was relatively expensive. Now we have a circumstance where there are now incentives, cash incentives, that make solar payback in 3 to 5 years here in Illinois. Why is that payback period so short? Well, let's look at some of the costs and benefits. We have the energy to grid. This is 5-year return on investment. You're going to get about 20% of the cost of a solar array back in grid energy savings. Then we have SRECs, solar renewable energy credits. That's a cash performance-based incentive. 1 megawatt hour of electricity that the solar array produces is 1 REC. That's going to accumulate in the first 5 years to 30 to 50% of a project's cost being paid back to the system owner on a quarterly basis. Then we have something called the Smart Inverter Incentive. This is something that the Illinois Commerce Commission is incentivizing, and that's about 10% of a project's value. Then another big one here is the federal ITC. That's the investment tax credit. We currently have a 30% tax credit on solar projects all over the country. So if you spend $100,000 on solar, you're getting a $30,000 tax credit. And then we have something called bonus depreciation. There's all kinds of equipment depreciation that businesses can use. The most common one is makers. And solar has a special form of depreciation now known as 100% bonus depreciation. That's about 20 to 25% of a system's value. So you see here in years 1 through 5, you're break even and getting into cash positive upwards of 120% of your ROI. So what are the incentives and energy savings on a small commercial system? Here I'm modeling a 55 kW DC solar array like we have here in Oak Brook at our facility. The capital expense is around $137,500. The energy bill savings are going to be $27,000, a little more. The SREX and smart inverter are going to be $55,000. So you see that's about a little more than a third of the project's value in cash incentives. Then you have the tax credit, which is 30%, $41,000, and 100% bonus depreciation, $34,000. So the 5-year net savings of $20,000, we're already in the black in year 5, and 25-year savings of $122,500. So you see that you buy a power plant, it pays for itself in years 1 through 5, and then you have free energy for the remaining 20 years of the lifetime of the system. Solar arrays last for 25 years, and it means real savings. Here's a cash flow for a large commercial system. This is a 2.45 megawatt or a 2450 kW solar array. The capital expense is quite large. This is a big facility. We're talking hundreds of thousands of square feet. It's $4.2 million of investment on the front end. Not that you have to make that investment yourself. There are third-party financing methods. So give me a call, send me an email, chat me up at TG Montague on Twitter. Energy bill savings on a project like this in the first 5 years are going to be close to $1 million. The cash incentives, that means the SREX, that's solar renewable energy credits, and the smart inverter incentive, upwards of $2 million. We're looking at 50% of the project being paid back to you in cash in the first 5 years. Then you have the tax credit, that's the federal ITC. Be warned, the federal ITC is going to step down starting at the end of 2019. So you need to have a sense of urgency. The incentives for solar are no sweeter. They are sweeter now than they will ever be again. And then we have accelerated bonus depreciation, close to $1 million. All said, in the first 5 years, you're cash positive to the tune of $930,000. 25-year savings, $4.8 million. So you can just think of it this way. You make a capital investment on the front end, in this case, $4.2 million. That pays back in the first 5 years. And then you're getting 20 years of free energy because sunlight is free. Solar converts sunlight to electricity. And you're saving a total of $4.8 million over 25 years. The alternative is do nothing, do not put a power plant on your roof, and that money is just going out the door to the utility. So which facilities can benefit from solar energy? Does solar work for everybody? Let's find out. In general, the bigger the bill, the bigger the benefit. You have to have a sunny rooftop or a piece of ground to put the solar array on. Obviously, solar makes electricity from sunlight, so it has to be exposed to the sun. Trees can get in the way if you have a very low facility. Obviously, that's a bigger issue for residential. We only do commercial here at Continental, and trees are seldom a concern, but there are trees around some facilities that you have to take into account. The roof does need to be in good condition if you want to do rooftop solar. Rooftop solar is great because what else are you doing with your roof otherwise? Of course, it protects your facility from rain and weather, but you could turn your roof into a power plant. You put a solar array on your rooftop and it makes free power. Those are the main considerations for the facility. Here's some examples of solar projects that we've done in the Chicagoland area. We've done over 50 solar projects. We've installed upwards of 20 megawatts of solar now in Illinois, which makes us the largest solar installer in Illinois. So what kinds of facilities benefit from solar? I'm going to give you 4 quick examples: Clark Environmental, North Central College, Grays Lake High School, and Apt Electronics. 2 of the projects are pure solar. 2 of them are solar plus storage. Just a reminder, you put these black panels on your roof, right? Those are the solar panels. That's semiconductor-based technology. The sun shines on the panels. They produce electricity in DC, direct current. Then it goes to a box called an inverter that converts the DC to AC or alternating current, which is what we all use in our homes and buildings. So this then gets used locally for lighting, equipment, televisions, refrigerators, computers, etc. If there's any excess, then that goes out onto the grid. So it's a grid-tied system, which is the most common form of solar. Solar converts sunlight to electricity. It goes rooftop DC to AC to building to grid. It reduces your kWh consumption, which saves you money. Electricity costs money. If you run a factory, you're paying tens of thousands of dollars a month to pay for electricity. If you could cut that bill in half or a third, which solar can do, that would be tremendous savings. It can be roof mount, ground mount, or building integrated, and I'll give you an example of what I mean by building integrated here at Clark Environmental in St. Charles. This is their headquarters. Clark is a very environmentally minded company. They wanted to show off that they were investing in solar. They obviously did a rooftop solar array here. You see that on the top of the building. We do very low tilt ballasted solar arrays. This is a 10-degree tilt ballasted system. So it's just weighed down with ballast blocks. There's no roof penetrations. Then we have an awning here, which is integrated into the building. That's what we mean by building integrated. And then we have a carport. Carports are great because they create shade, right? Keep the cars cooler in the summertime. And then they've got electric vehicle chargers. So the solar is charging the charger, is charging the electric vehicles. Very cool, very modern. In 10 years, this will be common. We will see tons of EVs, EV chargers, and carports. Here's Grays Lake High School, North and South high schools. In the bottom right of the slide here, you see the rooftop arrays that we installed, and then a large ground mount. This is a 1.4 megawatt ground mount, 4,000 solar modules, 2 acres. This was a performance contract with an ESCO, an energy services company. It saves the school district millions of dollars. What about solar plus storage? Batteries provide additional value. So they store solar energy, they provide backup power or resiliency, and they provide grid services like frequency regulation. Here at North Central College in Naperville in the western suburbs of Chicago, they installed a large solar array on the Res Rec Center. This is the largest facility on campus. It's one of the largest rooftop campus arrays in Illinois now. And then this container, which you see a blow up here of, it's nestled right there on the roof. It's like a small shipping container. This is a 250 kW battery. This container is conditioned because the batteries like to be at a constant temperature. And the battery is then storing solar energy, providing backup power to the facility, as well as providing grid services, in this case, frequency regulation. We work with a software provider called Intelligent Generation that makes software that talks to the battery, that talks to the grid, and it conditions the power on the grid. And for that, the grid operator, in this case PJM in ComEd territory, gives you a small fee for those services, and that helps the battery system pay back. Then we have another similar system, 500 kW rooftop solar array here at Apt Electronics in Glenview, paired with a 500 kW battery storage system from Tesla. Isn't that sexy? That white and red container. Tesla has a wonderful looking product. This is just sitting on a concrete pad outside the facility. Same thing here. The battery is providing backup power to the facility. It's providing grid services and resiliency. They can use this battery for passive income by providing grid services, but they can also use it in the case of a capacity day. So if there's going to be a super hot day, they will program the battery to be fully charged in the afternoon when the demand charges are going to be higher than normal because the grid is functioning at capacity. And the battery can then offload or provide power to the facility to reduce the amount of electricity that the facility consumes from the grid, thereby leveraging the battery as a source of revenue. And that's how batteries pay back. Solar plus storage is a great way to leverage your solar in the case of a grid outage because you can create a microgrid. Normally, a grid-tied solar array gets shut off when the grid goes down. That's by code so that any first responders that are working on the lines or working on a facility do not get electrocuted. So most people don't realize this, but if you have a solar array on your roof and the grid goes down, you cannot power your facility with that solar array unless you have a microgrid. And that means having a battery or a generator that can then reboot the solar system, island from the grid, and then go into microgrid mode. Then you can use the solar to power your facility and charge your battery. Here are 3 slides that explain a little bit about how batteries work. This is just showing the base load, right? The demand for electricity tends to be highest in the middle of the day when we're running all of our air conditioning and electronics. Now you add solar, and you're knocking down that load in the middle of the day with the solar energy. So the green area, the orange area is what the solar is offsetting. And then the battery comes into play and it charges in the morning and it discharges in the afternoon to knock down those capacity charges. So lastly, why is Illinois a top solar market now? Solar has ebbed and flowed in Illinois. We had about 100 megawatts of solar going into 2018. We are now going to add 3,000 more megawatts of solar in the next decade, thanks to the Future Energy Jobs Act. We also call that FEJA. Now, Illinois got a renewable portfolio standard in 2009 that says that we're going to make 25% of our power from green energy, that's wind and solar, by 2025. We were not meeting the goals of that RPS until FEJA came along and fixed that problem. What FEJA does is it says that the utility should collect a fee, so ComEd and Ameren and Mid-American are collecting on all of the ratepayers' bills, that means all the businesses and all of the residences in those territories are feeding into a fund that is then paid out to solar system owners. That is $200 million a year subsidizing the solar industry, and that is fueling massive growth. We also have the federal ITC, that's 30% until 2020, and then it's going to step down starting in 2020 down to 10% in 2022. So that is like a cash incentive. It is a very generous tax credit. Like I said, if you spend $100,000 on solar, you're getting 30% of that back in a tax credit. What this means is 3,000 megawatts of additional solar or a 30-fold increase in the solar installations in Illinois in the next decade. So act now. These incentives will only decline over time. I do want to make a note about upcoming webinars. We do this webinar on the last Tuesday of every month. You can find them at seco.com/solar webinar. Registration is free. You do have to register to catch the live event. We also post all the recordings and our slides on that same landing page. On September 25th, it's my pleasure to host Sean Moran, Senior Project Manager with Skender. We're going to talk about getting to net zero with solar energy. So we'll be talking about green and efficient construction, and then how renewable energy gets you to zero or net zero energy on site. Then on October 30th, we're going to talk about batteries and solar, maximizing your solar investment by adding battery energy storage, featuring Travis Simpkins. He is the founder and CTO of MuGrid in Colorado. He is a nationally recognized speaker and expert on microgrids and energy storage. So we're looking forward to having Travis on the show. Thank you so much for joining the webinar today. We really appreciate you. Please reach out to me, tmontague@cecco.com, or SECO as we say. My phone number is 217-722-0429. and we are right here in Oak Brook. So please visit us. I also host a monthly meetup called Chicago Solar and Storage. You can find that on the meetup platform. We do a monthly roundtable discussion here at our offices. Thank you so much. Have a wonderful day.